we get to these types of rules. By the way, if I saw a problem like this, I would look on the inside of the parentheses just to see if it's possible to simplify any of those. But right here, just with the x and y, no, I can't simplify there. Same with this fraction. Again, I would look to the 3 and 2 to see if I could simplify there. Or if I have like an x on the bottom, maybe I simplify there first. So we're almost looking at an order of operations situation here where you would look inside the parentheses. But if you can't simplify the inside of the parentheses, then just work with what you have. Okay, so let's start with this one. Okay, now the x and y here do have exponents, and this is where a lot of students make mistakes because it's like, well, there is no exponent for those. There is, you just can't see it, which makes them phantom ones, right? Now, does it help you to show the phantom ones? I don't know. Hopefully it does, because that's what I'm doing right here, but not all students need that. So why did I do that? Is because I'm going to take my bases of x and y, and while right now we have exponents of 1, like I said a few slides ago there when we were looking at the rules, this 5 exponent gets distributed into the parenthesis exponents. Now when I say distribution, I'm talking about original distribution, which would have been multiplication, so it's just multiplication though of the exponents. So that's why I've got x to the power of 1 times 5 and y to the power of 1 times 5 as well, which then gives me x to the power of 5 times y to the power of 5. And again, that would be all for that one. And yeah, by the way, if you want to show that multiplication between, you're welcome to. It's just more work than I want to do as a math nerd. So if you're thinking, wow, this is pretty awesome stuff, it is. Or maybe you hate it still, I don't know. But we're going to be using these now, like on this one, we're just looking at each one individually, but we're going to start looking at these combined, so be aware. So again, I'm going to have the exponents of 3 and 2. I want to see those phantom ones there. I see the exponent of x is already 3, no problem, right? So this new fraction, again, I've got bases of 3 and x in my numerator, and then 2 in the denominator. Right now they have exponents of 1, 3, and 1. But this 3 exponent, now that I put in purple, I'm distributing into the parentheses, right? Into all the exponents in the parentheses. And when we say distribution, we're talking about multiplication. So I've got to show multiply by 3 for all the exponents. So this should not change my bases for now, but it will change the exponent. So 3 to the power of 1 times 3 is 3. X to the power of 3 times 3 is 9. 2 to the power of 1 times 3 is 3. And yeah, we can, just in case we need to, we can evaluate that. 3 to the power of 3, again, just put that in the calculator, and you will get 27. 3 times 3 is 9, times another 3 is 27. 2 times 2 is 4, times another 2 is 8. And then we still have that x to the power of 9, which cannot be evaluated. So this one, it looks good.